So I've covered a lot of detail on this channel around CO2 lasers as well as diode lasers. And we've built many projects, and you can see certainly what they are capable of. But one laser type I haven't covered on this channel is one of these. This is a fiber laser. It's an entry-level laser from ComMarker, the B4. And in this video, I'll review it. I'll take it through its paces, and you can see whether this is a laser you're going to want in your shop or not. Now, if you're coming from the diode laser world, the thing you're going to notice most is this thing is blistering fast. And with that, we'll get started. Hey, how's it going, everybody? Steve here. Welcome back. Now, ComMarker reached out to me a while ago and asked me if I wanted to test their new B4. This is their entry-level fiber laser. This particular sample that you'll see in this video is a 20-watt fiber laser, but these are available as high as 60 watts. Now, one of the things you have to understand with a fiber laser as an entry-level laser is it's not going to be a $500 laser. This is not the diode laser market. Entry level in the fiber market is $2,300, $2,400 in US dollars. So they tend to be a lot more money, but some of the things they can do are things you can't do with either a CO2 or certainly a diode laser. And I'll walk you through some of those differences. And with that, let's take a quick flyover here. So when your laser arrives, it'll come in a big box like this, and you open it up and there's a bunch of things inside. There's a 200mm lens, a set of goggles, a bunch of samples, a foot pedal if you're doing mass production, and then the laser head itself, the control electronics in the middle on the base, and a pedestal to hold it all together, as well as some documentation. Now, mine also came with a rotary attachment, which is basically a chuck on a stepper motor plus a controller for it. This just plugs right into the back of the laser, and there's really nothing else you have to do. So once you get the laser together, you'll see that on the front panel there's a power switch, an emergency stop button, which is important, and then two buttons for up and down. Now, there's also a manual raise and lower of the laser if you want maybe precision. Flipping around back here, you can see the laser is on a fairly long cable between it and the controller, and that's because you can remove the laser and use it remotely. There's a couple of connectors here as well. One is for the rotary and the other is for the foot switch. I won't talk a lot about the foot switch here, but basically you can configure it so that every time you touch the switch, it will restart the job that you have in Lightburn or EasyCAD. So it's fairly simple. I don't do mass production, so I won't talk a lot about it here. So the only real thing you need to do with the laser is control the focus, and you can use those up and down buttons on the front panel as well as the knob I mentioned. And all you have to do is bring those three laser dots into a single dot in the center, and you're in focus and you're ready to go at that point. Okay, so I'll start with my standard dog photo here, and you can see it's in progress. This is real time. Now, the thing you're going to notice, of course, is that this laser is so much faster than either a CO2 or diode laser, and that's because it's a galvo laser. So rather than having heavy gantries and laser modules to move around, all it has to do is move two mirrors inside the laser to steer the beam around, and you can see the output there. That's exactly what it's doing. Top speed here is about 15,000 millimeters a second, which is substantially faster again than those other two types of lasers. And when you get this right, the results look spectacular, and that's because the laser spot size here is about 45 microns, so 0.045 millimeters, with the 110 millimeter lens. Now, if you're using the 200 millimeter lens, you get roughly twice the work area at 200 millimeters square, but then the spot size goes up to 0.065, and I'll say that's gigantic, but it's still roughly about the same size as a diode laser at that point. So the specs are really good. You can see the output looks fantastic. Next, I tried to print some business cards, and this is what I have on the back of my business cards because I have two-sided cards. And what it's doing here is engraving a couple of QR codes in real time. Now, you can see, again, this is really fast. I was making these on my CO2 laser, and it was taking me probably 2 minutes to make the back side of this card. And here you can see it was just maybe 20 seconds, very, very quick. One of the new materials that you can engrave here that you can't with either of the other two types of lasers is aluminum. And here I'm just doing a speed versus power test. Now, these lasers also have an additional facet, we'll say, which is frequency. And You can also, in Lightburn at least, you can also do this kind of test, material test, where you do power versus frequency or frequency versus speed. So you can see the effects of what they do. When in doubt with some of these new materials that you probably haven't worked with before, always run one of these material tests, and you'll get a kind of a feel for how the laser behaves with that kind of material. Now, I had these 2-inch diameter brass ingots that I use around my shop because they're heavy and I hold down material with them. And you can see we can also engrave that, which is also something you've probably not seen before. And you actually can get some interesting color variant here that you don't normally see with something like aluminum. And when you're done, we'll zoom in here and you can see the grid of the speed versus power looks pretty interesting. So there's some things we can do with this. So with that in hand, I put together a Mayan calendar that's roughly the size of the surface of one of these brass ingots. And after a fairly lengthy process, this took about an hour and 45 minutes probably. I ended up with something that looked like a really nice result. And you can see the detail there is pretty concise. It's exactly what I would expect it to be. The engraving is reasonably deep as well. It's not, I don't know if I'm down to the 0.3 spec that ComMarker says they can get, but I really didn't have the patience to let this run longer. So the result is there. It looks actually really nice. So next I decided to tackle some stainless steel, and I did a bit of a different material test here. This one is frequency versus interval time. And the hope here is that I get some annealing happening so I can get some color in the stainless. Now, I seem to have succeeded because when you look at the result here, you can see there's all kinds of color in the output. And we can use that to our advantage if we really want to. We can make colored engraving on stainless, and that's something diode lasers talk about, but it's not something that's predictable with a diode laser. And here you get a much better control over doing that annealing to get the color. So still with stainless, I took one of their dog tag samples that they provided and I put my logo on one side. This is a deep engraving. That one will be about 0.3 millimeters. And then on the other side, I did the high mark approach for stainless engraving and got some really dark lettering there. So still in the dog tag bag, I found these black anodized, I believe they're aluminum tags, and I decided to put a photo on it. Little memento. I have some guests coming and maybe they'll get one of these, and you can see the output there. The photo looked amazing and text was nice and crisp. So the last thing I wanted to do was test out the rotary attachment, and you have to set it up first in Lightburn. I don't honestly know how to do it in EasyCAD, but I'm sure there's a way. Go into rotary setup, select chuck, and the number of steps per rotation on this are fairly high, so 12,800, you make sure you set that. You want the y-axis rotation, and then the diameter of the object you're doing, which in my case is a ring that came in the sample package, and that's all there is to it. And once you're there, you can enable the rotary as well. In my case, I turned on the direction reversal, and it's just a function of which side